Hi, in this video I'd like to talk about the Humanize library. As usual, the Jupyter notebook that we're going to do here is in the GitHub repo that's linked below this video. So first of all, what does that library do? Well, basically it's used really for display purposes. So from a display perspective, let's say that you're showing to a user the number of bytes that a file is. Would you rather show something like this over here, or would you rather show something like this? Obviously, this is a much better approach just to give somebody an idea of what the file size is. Now, later we'll go and talk about the K, M, and G. What is, the G versus GI, and whether we're talking about factors of 1,000 or 1,024, because there's confusion around that. So we'll talk about that. So in order to write something like this, to display like this, we could certainly do it, right? We can just start dividing, doing integer division and getting from bytes to gigabytes. But of course, you've got other problems, right? Where if you've got this number here, you might want to show this as terabytes. This number here, you're going to want to show as gigabytes. So now you've got to think about the magnitude as well. So it's actually quite involved, right? There's a lot more going on than just simply always dividing by the same factor and then just saying it's always going to be gigabytes. Sometimes you may end up with something where representing 100 bytes as gigabytes just isn't even going to show anything. It's going to show you 0.0 gigabytes, right? Now, similarly, you have things with numbers as well, where when you have large numbers, maybe you want to put the commas in between, or maybe you just want to display it more like this, like an approximate 1.5 billion. So the Humanize library is what does it, and you can find the documentation here. And basically you have things for humanizing numbers, times, file sizes, and you even have this thing here called I18N, which is just basically a short form of saying internationalization, this one over here. So we'll cover a lot of these things in this video. Now, another thing you may want to look at is the actual GitHub repo itself, which is linked also in that notebook. And this basically, you can see a variety of things. One of the things that you'll find is the name. This is in the setup.config. The documentation is maybe a little sparse sometimes with this library. One of the things, for example, it doesn't tell you is, well, what do you actually pip install? Well, you look at the name here, that's what you pip install. You pip install Humanize. There's other parts of the library that you may want to look at as well, in particular under the source Humanize. For example, for numbers, you can look at the code and you can see what functions are all available, like ordinal, and there's actually good documentation there for these functions. If you look at the actual documentation that I linked earlier, not everything that's actually implemented in the library is documented. So sometimes you've got to go back to here to actually see what's there. But I'll mention that in the video as we move throughout it. So the first thing that you'll want to do, of course, is to pip install that library. So pip install Humanize. And then once we have that, we can basically import Humanize. And let's look at numbers first. So there's actually quite a variety of ways we can format numbers using Humanize. As I mentioned, some of the options are included in the docs, but many of them are not, so you'd need to look at the code itself that I just showed you. So let's take a look at an example of adding 1,000 separators to numbers. The library itself is very, very easy to use. So we can use this int comma function that's in the Humanize library, and let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.45678. And if we do that, you can see basically it just adds in those commas. Now here's a couple of formatting options that are not mentioned in the docs. One is for converting numbers to their nth version, like saying the first, second, third, fourth, and so on. So let's try that. So we'll say for I in range, let's say 11. So we'll go from 0 to 10. And we're going to print, and we're going to humanize, and we're going to use this function called ordinal. And we'll pass in this ordinal number I, this integer. And when we do that, you can see that it basically can do 0th, 1st, 2nd, 3rd, 4th, 5th, 6th, etc. Now another one is for limiting the number that you're going to display to be between a floor and a ceiling. And that's actually a really interesting one. So we can look at humanize.clamp, and it's called clamp, and you want to clamp a number, and then you specify what the floor is. and you specify what the ceiling is. And what it does, it's basically going to try and represent the number between that floor and a ceiling. And if it's not within that, it will tell you if it's less than the floor or greater than the ceiling. So in this case, it would tell you that this number is some number that's less than 100. If we were to take the same thing and do, let's say, 280, now that's greater than 200, you'll see it will tell us that this number here is greater than 200. Now another really interesting one with numbers, and it's also not actually documented, but it is in the code, it's the metric function that will basically humanize values using the standard SI prefixes. I have a link in the notebook to a page that lists some of the standard SI prefixes. For example, you can see that things like kilo is K, it's 10 to the 3. Giga would be a capital G with 10 to the 9. And then you also have the negative powers of 10 with deci, centi, milli, micro, nano, and so on. So let's take a look at how this actually works. So we're going to humanize, and here we're going to use this function called metric. And we'll humanize metric with, let's say, the gram, right? So if we do that, then basically it's going to come back and say this is 1.23 kilograms. Basically it divided by 1,000, then we got the 1.23, and then it gave us the kilograms instead of grams. We can also look at things like, for example, humanize.metric, and we can take 0.0001 and let's say Faradays. So if we do that, and if I spell it right, you see that we get 100 microfarads. So this is an interesting one. You can also deal with floats and scientific notation. For example, we could say humanize.fractional, and we'll say fractional 3.14. And what it will do is basically give you a rational version of that float. So 3 and 7 over 50. Of course, these are all approximations, but that's a good approximation to display. You can also do scientific humanization. So you can humanize a number, for example. You use the scientific function. Let's say we pass it 0.5. Well, in scientific notation, it's 5 times 10 to the negative 1. So instead of writing it out like 5e01 as you would see very often, you can see that it's using the x here for the multiplication symbol. It's using a superscript for the negative 1 and so on. Let's take a look at another one. Let's say that from math, we're going to import pi and sine, for example. And then I'm going to humanize, and we'll do scientific. And we're going to take sine of pi over 3, for example. And here, I'm now going to use an extra argument here that I can pass to scientific, which is what precision do I want, right? This precision here was kind of automatically calculated by humanize, but I can actually specify the exact precision that I want. So if I do a precision of 10, I get that. If I do a precision of 2, I'm going to get just 8.66, right? So basically you can control that a little bit. So there are a few more number-related functions that are documented, so go ahead and check that out in the documentation. Now, humanize is also really handy for dealing with date times and time deltas. So let's look at the natural time function. And first thing is I'm going to, from date time, import date time. And let's go ahead and humanize, and now this is called natural time. So natural time. And we'll take datetime.now. Now, datetime.now, now is my local time, right? Keep that in mind. And so when I humanize that, you'll notice it doesn't give me a date, it just tells me it's now. Notice that this means that the point in time relative to which this difference is calculated, right? This difference that natural time is calculating is based on the local time by default. In fact, this would make it very clear. Let's go ahead and again humanize natural time. So natural time, and we'll take date time, but this time I'm going to do UTC now. So obviously UTC now, I'm in Arizona. I am basically 6 hours behind UTC currently. So if I do that, you'll see that my natural time says 6 hours from now. Well, obviously that's not correct, right? Because I am not 6 hours from now. My now, even in UTC, is now. So you really can tell Humanize what that reference point is. And we can fix that by using the when argument. So let's go ahead and do that. I'm going to take this over here, and now I'm going to say when equals datetime.utc now. So basically I'm telling natural time to give me a natural time based on UTC now and with respect to UTC now, not with respect to my local time. And so when I do that, now it tells me now, and which is correct, right? Even though I'm doing this time in UTC, it really means now as far as I'm concerned. Since we really want to be working with UTC times inside our code all the time, and you only want to basically convert to and from other time zones as you're either getting data in or you're displaying data outwards, everything else is going to be in UTC, you're most likely going to be using this fairly frequently. So let's look at a few more examples of how Humanize deals with absolute times. So I'm going to import from date time, I'm going to import time delta. So I'm going to use some time deltas. And I'm going to say when equals date time dot UTC now. So basically I'm using that just because I want to kind of fix things. And now I'm going to say D1 equals when plus time delta. And I'm going to say the time delta is days equal to 1, minutes equal to 3, and we're going to do seconds equal to 23, for example. And then we'll do another time, D2, and this is going to be when minus time delta. And we're going to do 90 days and 3 hours, let's say. Right? So we're going to subtract 90 days and 3 hours from that. So we can certainly look at D1, okay, we get that, D2, we get that. That would be the normal display. We could even do an ISO format if you wanted to, right, on each one of those. So let's go ahead and humanize natural time. And we're going to humanize D1, and then we'll specify the root, basically, of when equals when. And you can see it says a day from now. So you can see how humanize changes those times into kind of relative terms. Now we can also do the same thing for natural time, and then we'll do it with D2. And again, I'll specify when equals when. And you can see it now says 2 months ago. So this is when you're humanizing absolute dates and times. It basically tries to convert that date into kind of an interval and gives you an, here an English description. We'll talk about internationalization later. Gives you an English description of that date in terms of a delta. Humanize can also work with just deltas, time deltas directly. The only thing is you're not going to see things like from now or ago. You're just going to look at and get something like a day or 2 months. So let's take a look. We can go ahead and say humanize, and we'll say natural time, natural delta in this case, because we're dealing with a time delta. And we can go ahead and create a time delta. So let's do time delta. Let's say minutes equals 10, seconds equals 30, and then milliseconds equal to, let's say, 200. So if we naturalize that, then we get 10 minutes. Okay, so this was a time interval of approximately 10 minutes. When we deal with time deltas that are less than a second, so let's take this, I'm going to copy paste this, and I'm going to remove the minutes and the seconds. So my delta is really just in terms of milliseconds. Then you see it gets naturalized to a moment. So this is, a moment in time. It's a small moment. Now, if that's not good enough, you can actually tell Humanize to lower essentially the minimum unit that it should use. And we do that by specifying minimum unit as an argument to natural time, to natural delta. So we'll say minimum unit equals, let's say, microseconds. Or let's start with milliseconds. And you can see it tells us 200 milliseconds. If we want to do an example with microseconds, we can do microseconds here. And if we then go ahead and do that, we get a moment, of course, but if we then put in this in terms of milliseconds, well, this is now going to be 0 milliseconds. So that's not maybe good enough. Maybe you want to go down to microseconds, in which case you just specify microseconds for the minimum unit, and now you get 200 microseconds. So the next one to take a look at are file sizes. So these functions are handy for displaying file sizes in more human-readable fashion. Let's say that we're going to humanize, and here we're going to use the natural size, so natural size function. And let's say we're going to take 1024 bytes. And this gives us 1.0 kilobytes. So we can specify the precision of that format number if we want to. All we need to do is to basically add a format argument here. And we can go ahead and say we want, and you use the %.3f. So you kind of use that notation. And this now is going to change and give us basically precision 3 digits after the decimal point. So let's talk about one very important distinction that we have to make. Is kilo 1,000, which is the decimal system, or is it 1024, which would be in the binary system? Now, typically, memory in a computer is measured in a binary system. So 256 megs of memory means what? It means 256 megabytes. So that's 1024 kilobytes times 1024 bytes. And that's actually equal to, you can see this number over here, 268,435,456 bytes. Okay, these are in bytes. Now, on the other hand, hard drive manufacturers use the decimal system. So for hard drive manufacturers, they say 256 megs is 1,000 bytes, right, or 1,000 kilobytes, and each kilobyte is 1,000 bytes. And so this is the actual number of bytes that you have in 256 megs. So as you can see, there's a difference between binary and decimal. So hard drive manufacturers were really the first ones to kind of use the decimal version. Before, in memory, we'd always used binary, 1024, basically 1024 bytes to a kilobyte, 1024 kilobytes to a megabyte, and so on. They decided to go with thousands, and I don't know, I mean, maybe there's a good reason for it. I just think that if you take this number here, and if you can now advertise your disk drive as being 256 megs. But if you take that number and you use the binary instead, then you would have to advertise that disk as 244 megs. I have no idea if marketing played a decision in this or not. But anyways, the fact remains that we do have this kind of confusion. So the IEC, the International Electric Commission, finally set some standards up regarding this. So you have the prefixes K, small k, capital M, capital G, capital T for kilo, mega, giga, tera. These are going to be decimal based, so factors of 1,000. And I explained this in the notebook that's in the repo. I also have a link to a Wikipedia article on that. So let's actually switch to that. And you can see that in the metric system, so this is when we're dividing by 1,000, we have KB for kilobyte, capital MB for megabyte, GB for gigabyte, and so on. When we're dealing with 1024 factors, so basically in the binary kind of mode, then we're looking at, the legacy was using capital KB for that, and capital MB, that was now confusion, which is it, and so on. So now the new way of doing it is using this KI, MI, GI, TI for kibibyte, mebibyte, gigabyte, and so on. So now, no more ambiguity. But that means, of course, that you have to use those prefixes that way. So let's go ahead and use now humanize, because humanize is able to make that distinction. So let's take a value, let's say 1 followed by 9 zeros, so 1 billion basically. And we want to get the natural size of this value. So again, now we're talking about file sizes. So now we're talking about things like memory size, file size, and so on. We're talking about dealing essentially with bytes. So we can do humanize.natural size, and let's go ahead and natural size the value. So let's say that you have a file that contains 1 billion bytes, then it is 1.0 capital GB being the metric equivalent, right? The gigabyte in metric. And in fact, you can see that we get exactly 1.0. However, if we want, we can say no, we want to use the binary version, in which case you just need to pass an extra argument and specify binary equals true. And now you get no longer 1 gigabyte, you get 953.7 megabytes. All right, so basically you can choose which one you want to display. So lastly, Humanize also supports localization or internationalization, abbreviated as I18N. When we look at certain humanizations, you'll notice that mine were in US English. Now, Humanize provides a bunch of local definitions, and you can always add one yourself if you need to. Now, the library doesn't document what those locales are, but you can find them, again, going to their GitHub repo. So if we go back to Python Humanize, and we take a look at source, and then we go to locale, you can see there's a bunch of locales in here. So we're probably going to have US English in there somewhere, unless that's the default, in which case you don't need the locale. But if you want UK, I don't know what half of these other ones are. This must be Russian. This is Italian. This must be Japanese. This is French, right? So you have the locales that have been implemented already, and you can add your own if you need to have something that's more specific for you. So how do you use them? Well, in order to use that, you need to activate the locale. And so that's kind of a global setting. So you can humanize.i18n.activate. And once you activate the locale, you've got to, well, specify first of all which locale you want, and it should be, the string should correspond to one of those strings over here, like ES, for example. This would be for Spanish. So when we do that, we now have basically the localization that Humanize can provide in that particular language. You can always see, by the way, what that file looks like. You just look at this humanize.po file, and you'll get basically all these translations, right? So you can take a look at that, and if you want to create your own, that's pretty straightforward. So now that we've activated it, let's take a look at some of our previous examples. Let's go ahead and take a look at this one, the ordinal, for example. You'll notice that my ordinals here were basically generated using English. Now I've set my locale to French. If I run the same code, you'll see that I now have it in the French version, premier, deuxième, troisième, quatrième, and so on. We can take a look at date times as well. I'm not going to bore you retyping the code. I'm just going to copy paste it. So this was when we were looking at the dates. And so now we get the French. Instead of saying the English in one day, in a day, this is dans un jour. Or 2 months ago, il y a 2 mois. So that's the French equivalent. So let's take a look at one more example. I've taken this locale over here, bn_bd. You can see that it is going to be in here, bn_bd. If we look at that file, you can see that it's there. And this is a Bengali language. Okay, so let's run this now. And you can see that this localization didn't change. It stayed the same. And that's probably because that file didn't actually, give you anything for the numbers. It basically kept, ST and second and so on, right? So it didn't provide any further localization for Bengali. But if you look at some of the other ones, like if we go to here for number 0, 1, 2, 3, 4, those do have that. So some of the functions that you have in the natural numbering, you're going to get that in that. And then the same thing with dates as well. You can see that those translation strings essentially were provided, right? So like a moment ago is going to be that, a second is that, etc. So if we run this example, You can see that over here now for the dates, however, that has been properly localized. So as you can see, it depends on how the locale definition file was created, whether it even exists, and then when it was created, what was actually added to it. Your mileage is going to vary based on that. So you may want to tweak those files, or you may need to create your own if you need to. And of course, if you are up to creating your own, it'd be a good idea for you to provide it back to that repo and basically contribute to that library with a new locale definition. I'm sure the author of the library would appreciate that help. All right, and that's the Humanize library. Thanks for watching.